In this unit, we're going to study polynomials. In this lesson, we're going to introduce some of the basic terminology we use when talking about polynomials.
All right. Hi, everybody. So in this lesson here, we're going to introduce the idea of a polynomial. And it's probably something that you're already kind of somewhat familiar with. You've probably seen this before in previous classes here. So a polynomial is an expression, mathematical expression, that has constants, variables, and exponents. And really, in terms of exponents, the ones that we're really most concerned about are the exponents on the variables. So just to be clear, if you've got exponents on numbers, then we're okay with that. We just consider those part of the constants. Now, however, a polynomial will not have, and here we go, number one, it will not have division by a variable. So division by a variable. So in other words, it won't look like this. You won't see like an x or a y or something like that in the denominator. Not going to happen. You will not see something with a negative exponent. You'll not see like an x with a to the negative 2. That will not show up here. Now, it turns out there's a relationship between those two. Okay, there's a reason why we have those even together on the same line, but we'll take a look at that a little bit later on here. Another thing that you won't see is a fractional exponent on the variable. So you will not see, for example, x to the 2/3. That should not show up in there. Our variables here, the exponents on the variables, should always be whole numbers. Okay? So you see an x, you see a y, you see a z in there. As a matter, the exponents should not be fractions or negatives. Now, a polynomial will also not have an infinite number of terms. It will have a finite number. Okay? Although there are times when you will see, and kind of I hope that at some point in your future you would take a class where you would study these expressions that have an infinite number of terms. They got some really neat properties. That's not what our interest is right now. That's not what we're looking at here. And you will also not see the root of a variable. Okay, you won't see a square root of x or like a cube root of y or something like that. Neither one of those is going to show up in a polynomial. So here's what you're looking at. Okay, with a polynomial. So there's your example right there. We've got 4 terms right there. And remember what it says down here, just like it says, and I'll highlight this here. Terms are separated by plus or minus signs. In other words, they're separated by addition. Whoops, sorry, I wanted to do that. Let me just erase what I just did there. You want to have the terms are going to be separated by addition and subtraction. And we don't want to have like terms. In other words, what we want to do is we want to combine like terms. Okay, we don't want to have a whole bunch of the same thing. Like, for example, we don't have an expression that's got 3x's plus 2x's plus x here. I mean, really, if I had that written down here, I would just want to put those together. That's 6 x's together. I have 3 of them here, 2 of them here, 1 more of them here. That's 6 x's total. Okay. Now, additionally, we do not include the plus or minus signs that are formed inside a bracket or a set of parentheses here. In other words, parentheses enclose a term here. So you might have, for example, x plus 3 here. As soon as you put the parentheses around that, that's considered one term. If you don't have it, if you don't have those together here, well, that's considered 2 terms. But with the parentheses there, that's considered one term. Now, let's label these things. Okay, we'll get used to kind of how we name these things. A monomial, okay, a monomial, I'm going to just highlight that, has one term. Just one term. Now, we don't want to kind of split hairs on this. I know that there's going to be people out there who say, well, wait a minute. Doesn't poly mean more than one? And yeah, I get that. I get that. But we're not being overly strict about that, okay? So any constant values are going to work as a monomial, as a single number here. Now, notice that root 7 works. Previously, I said that you couldn't have a root, but there was a little bit more to it than that. You couldn't have a root of x. That's no good. But it's okay to have a square root over a number, over a value. It's when you've got a square root over an unknown that's the issue. And then you could have 4x or 4xy squared by itself here. That's fine. And this right here is considered one term. Okay, it's considered one term. Now, if we go down just a little bit here, we're going to talk about binomials, okay, where you've got two terms. Okay, so our binomial here is where we've got two terms. Now, that could be 5x minus 2, 4x plus 1, 4x squared minus y. Or here, notice this one right here. This is the expansion when I multiply that out. As soon as I multiply that 2/3 through, when I distribute it through the x and the 1, okay, and I can do that, right? I can take that 2/3, multiply it by the x, I can multiply it by the -1, and then I get this. Then that's considered a binomial here. Just so we can see this here. Or what I can do is I've got my 2x, whoops, we'll make that red here. 2x times x minus 1, 4 times 5x minus 2. These are considered single terms. There's only two terms there. It might look like there's a little bit more going on, but those parentheses hold those together, and then multiplied by 2x, that makes that one term. That 5x minus 2 is a factor, multiplied by 4, that's one term. So that's a binomial. And then the last one that we're looking at here is the trinomial, and it's got three terms. So we show you a couple of examples here. And again, don't get thrown off by the fact that you've got a square root here or division right there. Because the variable does not show up inside the square root, because it doesn't show up in the denominator, that's okay. We don't have a problem with that. And then finally here, if you've got more than three terms, we just call it a polynomial. If you've got four terms, we call it a four-term polynomial. Oh, now it's going to go off the screen there. If you've got five terms, that's going to be a five-term, and I'll just say poly here, and so on. We're just going to label it now in terms of the number of terms that you see. And so here we go. A couple other things to pay attention to. The coefficients. Those are going to be the numbers that we are multiplying the variables by. Okay. Variables, those are going to be your symbols, typically letters from the alphabet, but the symbols that are going to refer to some unknown number. And then the constant is going to be the number that we have that isn't being multiplied by a variable, right? So the constant has no variable with it. And then our terms are all the expressions here that are separated by addition and subtraction. And so 2x is being added to 4y, and then we're subtracting the 9. Okay. Now, there is another way that we can look at that subtraction there, and we'll talk about that in just a couple minutes here, but those are our terms here. 2x, 4y, and 9. Well, actually, we could probably discuss this right now. Another way I could think about this is 2x plus 4y plus -9, in which case I might think of my terms as 2x, 4y, and -9. And frequently I find that it's useful to be able to think it through like that. Okay, anyway, let's take a look now at a couple of questions dealing with the stuff that we've just been looking at. Okay, so let's work through some of these questions here. So for each of these polynomials listed on the left here, we're just going to identify the coefficients, constant term, number of terms, and the name of the polynomial. So remember that the coefficients are referring to the numbers that we're multiplying by the variables in a term here. So in this case here, I've got one term, and the number out front here, the number multiplied out front here is 2. Now, the next one's asking for the constant term. And I can understand why it might be very tempting, for example, to say, well, 0. Okay, because when I take a quick look at this, I could write this conceivably as like 2x to the 6th plus 0. Now, the problem with that is, as soon as I write it like that, really the number of terms becomes 2. I've got this 2x to the 6th plus 0. But when you look at it, okay, that's not really a very natural way to interpret this first term here. It makes way more sense to just look at that and say, well, hey, wait a minute, there's just one term there. Okay. When I look at that, I don't see two terms. So it's probably better just to say that, hey, there's no constant here. And then there's one term, and this is a monomial. For the second polynomial, it's not nearly so complicated. When I look at the term with an x, I see that the number in front is 7, so it's going to be 7. The constant term is the value that doesn't have a variable multiplied by it, and that's just going to be the 3. There are 2 terms here, and that makes this a binomial. Now, this next one, it's got a little bit more going on. It's got 3 terms. Now, the coefficients here, there's 2 ways you could look at this. You could think of this as 3 and 3. We could look at this as subtraction, the operation of subtraction. Or what I could do is I could look at this as 3x to the 5th plus, and think of that negative as being part of that 3. And so I could see this as being having the coefficients of 3 and negative 3. Now, in either case, and it doesn't really matter because if I can be a little bit fluid with that, I can kind of go back and forth. It's okay. Everything's going to be fairly consistent there. The constant is just going to be 1. Number of terms, there are 3 here, and this is what we call a trinomial. Next, we've got 2 terms here. Okay, so I can see that right away here. Now, again, I can see this as negative 3 and positive 4, or I could see that negative as if it's part of that number there, that 4, and make it addition. I could see this as being add negative 4x cubed y. Just like the first one here, it makes more sense to say that there is no constant term there, in which case I know that this is just going to be a binomial. And now this last one. Okay, the parentheses hold those 2 together, the x and the 5 together. Now, the x is an unknown. Well, the x plus 5 is an unknown. I don't know what x is. I don't know what x plus 5 is. So the number multiplied out front there is 9. That's going to be my coefficient. Okay. Now, in this case, this is a monomial. There's only 1 term, in which case there is no constant. Now, but that is not the only way that this could be expressed here. I could multiply that through and make that 9x plus 45. In which case, the leading coefficient there, sorry, I should just say the coefficient would be 9. The constant would be 45, but this would look like 2 terms, and I would call this a binomial. So there are a couple of different ways that I can write this, and there are reasons why I might choose one form over another, and that you'll get into later on as you continue to move through the course here. So now for this next question here, which of the following are polynomials? Okay, we just have to identify what it is that we're seeing here. So for this first one, I'm seeing a value, just a number all by itself. That's it. That is a polynomial. The constants here, when we see them, would be considered a polynomial. It's a monomial. For this one right here, as soon as I take a look at it, I'm a little concerned about that square root. But because the x squared is not under the square root, the x squared is behind it. That's okay. This is still a polynomial. That's totally fine. For this next one here, I've warned you before about the denominator, about things being in the denominator, but because this is a constant in the denominator and not the x, I'm only really concerned if the variable shows up in the denominator. No, that works. That's okay. Now, this next one, though, okay, this one is problematic. This one's problematic because the variable is, in fact, underneath the radical. So no, that does not count as a polynomial. And in fact, this is what we call like a radical function or a radical polynomial. Oh, no, sorry, I shouldn't say radical polynomial. I'm sorry. Radical function would be the better way to explain it, or a radical expression. Here, this next one for e, notice that I've got this x to the negative 1. We talked about this before. We don't want the exponents to be negative. When that happens, this is not polynomial, and in fact, we would call this a rational. Over here, I have got an x in the denominator, and we just finished talking about that. We don't really want the variable in the denominator, so this isn't. This is also going to be a rational, and you might look at that and wonder, what's going on here? What's with the negative exponent being rational and this being rational? Well, there is a relationship between those two that you will explore it a little bit later on. Okay, so don't worry about that right now, but yeah, there is a connection there. And this last one right here, x squared minus 5x plus 12, well, there's no problems here. There's no variable under a square root. There's no variable with a negative exponent or a fractional exponent. There's no variable in the denominator. That's a polynomial. I'm happy with that. Okay, now for a moment here, we want to talk about one property of polynomials. We want to talk about the degree of a polynomial. Okay, and the degree of the polynomial is going to be determined by the degree of its terms, its individual terms. And so, what we mean by that, the sum of the exponents of the variables in a term is the degree of the term. In fact, I probably should say it like this. Okay, the degree of a term, just one term in a polynomial, is the sum of all the exponents of the variables in a term. Okay? Now, if you've got more than one term, then to figure out the degree of the polynomial, we just look at the degrees of each one and we pick the highest degree. Okay? The largest degree. So we look at each term, figure out the degree of each term. Whichever one is the largest, that's going to determine the degree of the whole polynomial. Now, it might help to give a little bit of a context for this. Okay? Later on, okay, we're going to see here that degree is linked to shape. And this is why it's significant. This is why we're interested in this. Now, right at this point in time, we're not going to make that link. We're not going to do that because we're going to play with things a little bit where that won't actually be the case, particularly when we're using like multiple variables like that. It's not directly the case there. I don't want you to think of it like that. But eventually it is going to be linked to the shape. And that's why this is significant. Now, take a look at this one here. So if the polynomial 7x squared y cubed plus 4x minus 9 has three terms, it's a trinomial. And I can write it like this. If you don't see a variable present, that's because the exponent on the variable is 0. At least that's one way to think about it. So I could think of this as 7x squared y cubed plus, well, there was no y in that second term there. So I can put one in, but put a 0 as the exponent. That last one, the constant, well, okay, I can put an x and a y in there as long as I put zeros in there. Now, if you add up the powers, okay, and I'll change color here. If you add up the exponents here on that first term, it's going to be 2 plus 3. So the degree of this particular term is 5. If I add up the degrees here, it's going to be 1 and 0. That's going to be 1. And if you add up the exponents here, it's going to be 0 plus 0 is 0. So I've got a degree of 5, a degree of 1, and a degree of 0. That means that the overall degree is going to be 5. This polynomial has a degree of 5 because that's the largest degree of all the terms in the polynomial. In other words, that degree 5 term is going to be, if you want to think of it this way, like the dominant term, okay, the dominant term in creating values. And what I mean by that is when you start plugging in numbers for x and y, this term here is going to have the largest impact on the value of those numbers, particularly as x and y get larger. The larger they get, the more that first term is going to dominate the value. Okay, anyway, let's take a look at some questions related to that. So this question here, it says determine the degree of each of the following expressions. Okay, so the nice thing is for this first one is it's just a monomial. Okay, so if I add the degrees together, and that's all I'm going to do, or not add the degrees, but add the exponents together, my degree here is going to equal the exponent on the x plus the exponent on the y. Now, if I had an exponent on the 3, it wouldn't matter. It wouldn't have mattered because normally what I would do is I would just evaluate that number, get the value. So if it was 3 squared, it would just turn it to a 9, and it would still be 9x to the 4th y squared. But in this case, I'm only interested in the exponents on the variables. I add them up, and I get a degree of 6. For this one right here, it's again, it's a monomial, which is great because I only have to consider the one term, but it's a constant. Now, in the previous question, we took a look at this and we noticed that, hey, you know what? If there's no variable there, I can write a variable as long as I give it an exponent of 0. And what that means is then that my degree of a constant term is simply going to be 0. The exponents are the sum of the exponents on the variables. Okay, now this one here is a little bit different. Okay, and a little bit different because I've got three terms here. This is a trinomial. So I'm going to put little ones over top of the variables where I don't see an exponent. And then I'm going to come up with the degree of each individual term here. So for this one, it's going to be 2 plus 1. This one here is going to be 2 plus 3. This one is going to be 1 plus 3. So the degree of my first term is 3. The degree of my second term is 5. And the degree of my third term here is going to be 4. Which means, therefore, and I put little dots there for therefore, the degree, the overall degree, is 5. Okay? That second term there, that is going to be the dominant term. That's going to have a huge impact on the value of this overall expression when a and b get large. Over here, I've got two terms. So again, I have to consider the degree of each of these ones individually here. But in this case here, the variable here, there is only the one variable. So the degree is just going to be the exponent on that variable, which is just going to be 2. And then over here, I don't see a variable. It's the constant term. So remember, I can put an x there as long as I put a 0 there, in which case the degree of that term is going to be 0. So therefore, the overall degree is going to be 2. Okay. Now, really quickly before we leave this, I want to take a look at just one other little idea here, and that's going to be standard form, the standard form of a polynomial, and we're going to link it to degree here. I'm just going to keep going with this because it is linked to degree. Okay, so the standard form of a polynomial is a way that we write it in descending order of degree. So in other words, we write it from the highest degree term to the lowest degree term. If that isn't enough to help me differentiate which one comes first, then what we do is we try to do them in alphabetical order as much as possible. So let's just have a quick look here. Okay, for these functions right here, I've got 4 minus 5x squared plus 2x. Now, I just saw a few seconds ago that the degree of a term all by itself is going to be the 0. The degree of this term is going to be 2. The degree of this term is going to be 1. So what I want to do here is I'm going to rewrite this in standard form by putting the negative 5x squared first here. Now, if you look at that as subtraction, that might make this a little bit confusing. It's probably easier to think of this as adding a negative 5 times x squared plus 2x. Just seeing it like that is going to help me when I make this next move here, because I'm going to move that one up front. So negative 5x squared, there's my degree 2. Here's my degree 1 term plus 2x. And then here's my constant. For this one right here, for this term, the degree is equal to 1. For this term, the degree is equal to 3. Now, for here, I have two variables, each with an exponent of 1. So my degree is 2. And then over here, there is no variable. So my degree, as we've seen before, if it's a constant, the degree is 0. So that means my degree 3 term is going to come first, and I'm going to do the same thing that I did the first one. I'm going to move the negative with it. So negative 5x cubed plus the degree 2 term, 2xy, plus the degree 1 term, 4y, and then plus 1, the constant. And now finally over here, for my individual terms here, a squared b, okay, that's going to be b to the 1. I'm going to look for any other individual little variables there without exponents, and I'll put 1s on top. So this is going to end up being 2 plus 1. The degree of this first term is going to be 3. The degree of this one is going to be 4 plus 3, so the degree is 7. Here, 3 and 3, the degree is 6. And then finally, here, 1 and 1, the degree is 2. So I'm going to start with my degree 7 term. And again, I'm going to move the negative with it that I see out front here. So negative 6, a to the 4, b cubed. Then I'm going to use my degree 6 term. So minus a cubed, b cubed. Then my degree 3 term, minus a squared b. And then finally, plus my degree 2 term. And when I write this, I'm going to write this in alphabetical order. Order does not matter for a multiplication, so I'm free to change that. And it looks better if I write it in alphabetical order here. And so there we go. That's what that would look like in standard form.